Hello everyone and welcome back. So in the past few months I've been learning about WebGL technologies and in particular the Three.JS library, which to be honest has completely changed my vision about web development. When I first learned about it, my mind was like blown, and as I learned more and more I came to realize how amazing this library is. Just look at their website to see what all you can do. So if you can to their website, it's 3js.org. They have like a lot of showcases here, and this is a library that you can do a lot of 3D rendering and animations, and we'll go into more details later. But if you look at their showcases, like for example this GitHub homepage, you can see like this earth 3D object here. This is all Three.JS and WebGL. If you go back to their website, there is like a lot of 3D stuff, cool stuff that you can do. Like this one here, it's like a 3D just kind of like a playground or something. So there's a lot of good stuff that you can find there. Also, don't think about it as a 3D thing only. You can like go to other showcases that they have. Like here you see all this cool mouse movement effects. This is all possible with Three.JS. If we go back to my portfolio website, so for example like this 3D model, I use Three.JS to import it and display it and like kind of like render it here. I'm using like Three.JS even to show this like page here, and then all these cool things that you see, it's possible with Three.JS. And of course I use GSAP library to animate stuff here. Or if like we go to my portfolio page, you will see that like I have this like cool animation. This is a little bit more complicated. I'm using shaders, fragment shaders and vertex shaders. I'll talk more about everything in my later videos, but right now in this video we are going to focus on more basics. It's gonna be an introduction to Three.JS and how you will you can import it in your website and like do some basic stuff with it. I'll probably have later parts to this video where I dig deeper and show you more cool stuff that you can do with this library. So before we get started, one quick note here. If you are new to this channel, please make sure to hit the subscribe button below and turn the notifications on so that you're the first to know when I publish cool videos like this. As always, first thing we're gonna do is to go to GitHub, this repo, and get the starter code for what we are about to do. I have a branch. At this point I have a starter branch here, so just navigate to that branch and then you can click here on the code, download the zip file or clone it and start working. I will add at least one other repo branch here for like the final code for this video, and if there will be subsequent videos I will also add those branches here. So once you download the starter code, you can open it in any IDE that you are using. I have VS Code here, so I've opened it. First thing we need to do is to npm install to make sure all the packages that we have are installed. All these files and folders that you see here, I have explained everything about them in my previous videos. I'll put a link, so many links throughout this video and also in the description of this video that you can go, or you can like go to my channel and find all those videos that I explain everything about these files and folders. So once you install all packages, the next thing we're gonna do is to npm start, and with that we are starting our dev server, and we're going to go to localhost 3000, and here this is basically the website that we've been working on. I've added this Three.JS here. I actually added like this new page that we will be focusing on today. This is where I will include all the new Three.JS stuff. So if we go to the Three.JS main website, in this left panel under documentation, they have very good documentation, and they have like a forum. You can go ask questions, and also of course Stack Overflow if you have any problems anytime. But we're gonna just go through this documentation, just set up our website to use Three.JS, and then we'll continue from there. I guess first thing we should do is to go to this installation section, and since we are using Node.js, we can like easily copy this code and install the Three.js package in our project folder. So once that's done, you should be able to see 3 they're right there in your dependencies, so that's all good. I'm gonna close this one. The next thing we should do, we should import our Three.js, and yeah, let's just do this first option. I have created, as you have seen my previous videos, all the front-end JavaScript that we have is under this app folder. I have pages, and then I have Three.js, and I have an index.js file. I have basic like code in there. I've explained everything in my previous videos, so make sure if you don't know how this is working, go check those videos out. And for here, I'm going to import Three.js. Just a quick note here, in my entry point for my JavaScript files here, index.js right under app, I have imported this Three.js index.js file, and I am basically using that here. Again, I've explained all these things in my other videos, so make sure check those out. Once we import our Three.js library here, I think we can move on to creating a scene here. So basically in Three.js we need 3 main things as they have here. We need a scene, we need our camera, and we need a renderer to basically render our scene and our objects and our DOM elements. I'm gonna copy all this code, and I explain everything in details. We want to make sure we put everything in our constructor here, and just to make sure I am following the pattern that I've been basically doing in the previous videos, I am going to add this keyword to these guys instead of defining constants, and make sure everything else is right, and I believe we are good now. So like I said, 3 main things. We have the scene, we have the camera, and we have the renderer. Our scene is basically our 3D, or like our Three.js scene, so that where we will have like our objects, camera, and everything in there. Imagine like a 3D software like Blender. you have, like, when you open Blender, first thing you see it's your scene, and then you start adding like 3D objects in there and your camera, everything. And then the second thing we have is a camera type. So here we're using perspective camera. There are other cameras here. You can, like, if you search like camera here, you probably see like different kind of cameras, but we're gonna focus on perspective camera as we have it here. And what these numbers are, I'm just gonna explain it through this sketch that I have here. So imagine like this is our camera, and like we are defining what parts of the scene we can see. So if I go back to this code, I have a field of view here. If you hover on this perspective camera, you see that the first number is field of view, and that's what I have here. So if I am saying it's 75 degrees, it's gonna see 75 degrees of like everything in front of it. So if I have an object over here or here, the camera is not gonna see it, so you won't see this in your website. But like if I have a circle here, or like a square, anything like a cube here, you can see everything here. Now when I say everything here, that's not totally true. What I should add is that we also have two other parameters here, and if I look at it, there is this near parameter and far parameter. And what that means is that if we go back to the website, it says objects further away from the camera than the value of the far or closer than near won't be rendered. So what that means is that if I have like 0.1 here, that means like objects within 0.1 unit of distance can be seen there, and if I have anything closer like 0.01 unit of distance, it won't be rendered. Or if it's like, if my 100, or what's that, like if 1,000 unit of far would end there, then you won't, all the objects here, they're not gonna be rendered, and therefore you won't see them in your page. So everything here between this minimum and maximum and within this 75 degree are gonna be visible. So that's, I guess, the easiest way I can explain it. And we also have this second parameter here, which is our aspect ratio. And if we go back to their website, it's basically just like a normal aspect ratio. And you almost always want to use the width of the element and also height, and or you'll get the same result as when you play old movies and the image looks squished. So you don't want to have that, so you make sure that you use the entire width of and height of your element that you're rendering. So that's a quick explanation for the camera. The third one is renderer. We're gonna use WebGeo renderer, and that's basically how we render our scene and camera and DOM element basically in our website. We need to set a size for that, and that's again the same aspect ratio. Well, not aspect ratio, we have a width and a height for our size, and that's what we see here. We're going to, since we have assigned this scene to the entire DOM element, you can see here we are adding it to the appending it to entire body. So it's gonna have a width and a height of our window. So if I save this here, and if I go back to my local host, and if I reload this page, you can see here now that this seems to be our render, our canvas, by the way. Yeah, so what we need a canvas to render our Three.js on, and that's what this line of code does. Oops. Here it adds a canvas, appends that canvas to the body of our website, and that's what you see here. Right before the closing body tag, we have this canvas, and if you look here right in this corner, you see the rest of our page. So obviously we need to do some CSS stuff, style our page, and to do that I have the styles for this page under my styles pages and Three.js. Everything I've explained all these things before, and before we do styling here, so I normally don't want to add this canvas directly to my body. So what I would want to do, and what I do most of the time, if we go back to our Three.js pog file, I normally add a container for my canvas to that pog file, and then append basically that canvas that we just saw to that, just so that I have a little bit more of control over it. It helps me to know where exactly that's gonna be. I know like with this method it's gonna be appended to our body, but the body of our website, but I prefer it to like have it appended to into one class in my specific page. So because you might have different Three.js scenes in different pages of your website, and it's good to keep track of which one is where. I will talk about this later. When you're switching between your pages, you would want to like destroy everything in your scene and then like move to the next page, and then if your next page has also a new scene, then like create that scene. So you don't want like not to destroy a scene and create the scenes on top of each other. And so having the canvas basically appended to a specific like class under your main like content of that page would help you to keep track of everything. So that's why I'm defining this new class here, and what I'm going to do, I'm going to assign some CSS styling to it, and it's basically going to be like my entire screen. It's going to be a fixed position, top and left of 0, and I'm just going to put it behind my text, because you might have like a link that you want to click on it. You don't want to put your canvas on top of it, and it wouldn't allow you to click on that text. I'll show you what I mean by that. And then in my Three.js index file, what I am going to do, instead of appending this render DOM element to the body of my web page, I am going to get that using query selector. I'm going to get that class, and then what I'm going to do is actually I need to get the width and height of that class, because now we are going to basically add it to that class instead of our body. So to get the width and height of our DOM element, which is this class right now, I'm actually going to use offset width and offset height. This is basically how you get the width and height of your element, and instead of all this window inner width and height, we will be using this dot width and this dot height. It's always good to kind of like console.log these numbers and see all those things, but since this is just a quick video about Three.JS, I won't do that, but it's good for you to like console that like stuff every step that you go through and see what you get there. So the next thing we need to do, instead of document.body here, I'm going to do this Three.js canvas and append that to as a child to this canvas. Let's see now what we have here. Localhost. So our console is fine, and you can see that basically I have my scene canvas here right under the container, and I have like this my text stuff up here. If I had put that to 1 here instead of -1, it would have probably blocked my text and I wouldn't be able to click on this text, and basically you can't see it. Now that reminds me of a couple things. So if we go back to Three.js here, our WebGeo renderer, we can actually add a few parameters to it. One of them is alpha, and with that we can make it kind of like alpha true, means that if we go back to our page, the background color, like the opacity of that, is gonna be set to 0. So basically you will be able to see anything behind that. And because if I actually go here and look at let's see, if we need to find anything, they have this search option here, and I can like do render here if you search, and then you have this alpha parameter here, whether the canvas contains an alpha transparency buffer or not. So the default was false, but like when I turn it to true, I make it transparent. That's the word I was looking for. Yes, transparent, and you can see behind. But since it's on top of it, the index is 1, you can like click on these things. And that's why I set the z-index as -1, so it's behind our text. If we refresh and reload this page, you will see I have my canvas here, but then I have also, I keep all my interactions with the text also possible. Okay, so now the next thing we need to do is normally we want to add like some kind of object to our scene, and to do that, if we go back to Three.js, what we can do is search for geometries. So all the like predefined objects that you can use, like box, circle, cone, all these geometries, you can easily like use the code that they have here and like import, kind of like render them in your website, and or you can like build your own 3D objects and then use some kind of importing library and import them. Well, Three.js will allow you to import all these other 3D models as well. So we'll talk about those things in some other videos. But for now, I'm going to actually use a box geometry, and to do that, I'm just gonna copy this guy here. We'll talk about all that, what everything is. Again, just to follow our pattern, I'm going to add our this keyword here. I don't think I need to do that for the geometry and material at this point. I'll do it for cube. And then I have this dot scene, which I will add the cube to. Okay, so let's see. We've added our geometry to the scene, our basically mesh to the scene, and so what we have here is a geometry and material for that geometry. So every object in Three.JS that we are basically we can use through the library directly is a mesh, and for that mesh we need a geometry and also material. Geometry is the shape of it, so if it's box, or if it's circle, or if it's like cone, cylinder, anything, all these geometries here. And in the material we have a few materials, but for now we're gonna use just mesh basic material, which is just like you're gonna put a color on this box. You can like see this, and you can change this color and some other parameters, but for now we're just gonna use this as our material for the geometry. And then you create your mesh using the geometry and material, and then you have to add that mesh, your object, to your scene. Let's see if we're gonna see anything here. So refresh. Well, at this point we don't see anything still, so let's go back to our creating a scene part and see what's happening there. Alright, if you copied the code from above, you wouldn't be able to see anything. This is because we are not actually rendering anything yet. So we need to actually start to render and add our scene and camera basically to our renderer. And to do that, I'm gonna copy this one, not exactly this one. I'm gonna like change a few names there. I would say this render, and then what I'm gonna have is just a render function here. This is basically the same, and the same animate function here. So I just call it render, and then what I'm gonna do, I'll copy everything here, and then so what it's going to do, it's going to basically request the animation frame for like basically every single like every second or even less than that. It's gonna go through this function over and over and then do the rendering of the page. I need to also change this to this dot render, and we need to bind this keyword so that we are able to do the rendering over and over again. That needs to be happening so that we can, like, if we make any changes to our scene, all that is reflected instantly. I need to fix this dot scene and this dot camera here, and after that should be, well, that should work, right? Just to add to make sure that this is being this is working, I'm gonna do console.log render here. I'm gonna go back to my page, and well, I need to fix something. This renderer, oops, this is supposed to be render, and let's see what happens now. As you can see, like, it's happening like over and over because we did the request frame request, animation frame, and this is being called all the time, but we still don't see anything here. So the reason for that is because if we go back to my sketch here, so we had our camera, and our camera by default is located at 0, 0, 0. So if we have like this 3 XYZ axis, our camera is gonna be in the middle, just like at our origin of our 3D scene. But we have here, our box is actually at 1, and it's not at 1 and 1. The center is at 0, 0, 0, but the width, height, and depth of it are 1 and 1 and 1. And so in our scene right now, our camera is at 0, 0, 0, and it's like inside our box, so we don't see anything. So if I move my camera a little bit further back, let's just do, we can do that by this camera dot position, and I can set it to let's see, I can set it to like 0, or I can do like 5, 5, 5. That means X, Y, and Z of 5. And if we go back again here, let's see if we can see it or not. Still we don't see anything. Now the problem is that when we move the camera will be looking directly ahead, but we want it, because our cube is in the origin, in the center of our scene, we want the camera to also look at the center of our scene, which is 0, 0, 0. And let's see if you can make, if that's gonna work or not. Yes, there we go. Now we have our cube, and it is right there. Normally, one thing that I think is good to do if you don't see your object in the scene, first thing you want to do is console.log your scene. I want time log, I want time this dot scene, and that way you can see if your object is added to your scene or not. How you can do that is, so you have this console.log under children, you should be able to see, like here I have a mesh, type mesh, and then I have the geometry here, which is a box geometry. So it seems like with width, height, and depth of 1. So it seems like it's there. If you can't see any children in your scene, then that means something wrong is happening there. So make sure like your geometry, material, and mesh is fine. You can like change the color obviously to whatever you want. And if we go back and refresh this guy here, here we have a new color. Now one thing that you notice here, this like these sides are a little bit jaggedy, and to fix that we can actually add another parameter to our render, and it's called anti-alias, I believe, and set that to true. Once you do that, that's gonna fix at least a little bit that jaggedy like edges. You see it's like much better now. You don't see that kind of jaggedness, and it's all better. Obviously you need to optimize your like website. If you don't really care about that, don't put so much power, like rendering power, you can just leave that as false as it was. But like if you want to do like a pixel perfect, not like super pixel perfect, but close as possible, you need that anti-alias to be true, especially if you like, later on I'll show you how you can put like different textures on your objects, and to make sure your textures look good, you might actually want you will end up adding this all the time. Another kind of like optimization for the renderer is adding a pixel ratio. So that you can do it using the set pixel ratio. You want it to be either 2 or your device pixel ratio. You don't want it to be more than that, so we'll do math.min. If I console.log my console.log, why do I keep typing this wrong? Okay, console.log window dot device pixel ratio, we can see like what my pixel, it's probably gonna be 1. Let's see, yeah, it's 1, and it's the case for most of devices, but just in case you have a pixel ratio of more than 1, you want it to be at most 2. So that's another like optimization or like enhancement you can make to your code. Another thing I suggest is to add access helpers. So if you go to the their documentation and search for access helpers, there you can find this here, and I'll show you what that is. I'm basically going to copy that here again, and this dot scene, add that access helper. I'm gonna comment out the render, and let's see what that's gonna add to our scene. As its name suggests, we're gonna see our like X and Y and Z axis. Z is basically in Three.JS towards like the outside of the screen. So like you're watching the screen, it's gonna be towards you, and that's like the blue line here, blue axis here. Then we have X, that was Z, towards you. X is gonna be to your right in the screen, and then Y is gonna be to basically up. So keep that in mind. Some 3D software that you use might have Z as up and Y will be like towards you out. For example, Blender might, I think, is like that. And when you're exporting your objects, your 3D models, they give you an option to like make sure Y is up, and that's what we need here in Three.js when we are importing any 3D models. So Y up, then you have X and Z. And if I change the position of my camera, if I put the X equal to 0, my camera is gonna be like Y and Z of 5. So what you're gonna see is this, because like Z was towards you, this blue yeah, this blue axis, and this is X. So X of 0, our camera is like on Y, and Z of 5, and yeah, that's what you see here. Let me see what else I can add here. There is another thing that I find helpful. By the way, you can animate this object also. It's easy. If you go back to create scene, you can add like the rotation or scaling or like position. anything of any of those you can basically change during this render process. So do I have cube up here? Yeah, it's cube. So I'm gonna say this dot cube, and then rotation. Let's only see Y rotation. Let's see how that looks. So it's gonna basically start rotating around the Y-axis, which is top, so you can see that it's rotating. So these are the things that are helpful. Later on in the other videos, I'll show you how you can use these things. Now, the other thing I was gonna talk about is orbit control. So if you look at orbit controls here, and this is something kind of like a cool thing. It gives you the option to kind of like drag the kind of I believe you will be dragging like your rendered area, and then you can see like the different sides of this cube. Let me just add that quickly here just to show you how that works. So this is actually the correct way to say it. Orbit controls allow the camera to orbit around the target. So you're basically orbiting the camera around your target, your object, and all you need to do, Three.JS has a lot of supplemental kind of like packages. One of them, orbit control, I believe, controls. And the way you can import them in your project is most of these guys are actually located under, if I go to my node modules here, if I find 3, almost there. If we look at this 3 folder, we have examples and then JSM. You have a lot of other packages here that you can use. What we're going to use is the controls and then orbit controls here. So if you have this like extension in VS Code that can like auto complete, suggest like the directories, you can actually use that. I'm gonna go examples, JSM, and then I have controls, and orbit controls.js is what I need. So that's how you import some of these libraries. One of them is orbit controls, and then all you need to do is to add this line here and add that to your basically code here. You need to like make a couple quick changes again here. This dot controls, new orbit controls, and I have this camera, and my DOM element will be this dot render dot DOM element. And if we save that, we can go back here, and now we should be able to drag basically our mouse on the screen, our cursor, and you can see like this is moving around, so you can look at it from different angles. This might be something you want to do in your websites, but I mean, if I go to this website that I built here, and like in the home page of this website, it's like an academic website. So we have this like 3D molecules here. You can like do that, like zoom in, out, you can like drag, and then different kind of models. So you want to show them here to kind of like interactively show them to your users. You can obviously use this orbit control to allow the users to do that. The other thing that they mention here is if controls enable damping is true, you need to add this controls.update. What this does is if I go to my here, if you see like I drag and like stop dragging, there is no like inertia or anything. It just stops right where I stop it. If I go back to my code here and add this line of this controls dot enable damping equal to true, and with that they say I need to update my controls here in my render function. So don't forget to add that as well, controls dot update. There should be a dot here, and then if I go back to this page here, now you will see like when I let go of the mouse, it kind of like there is some kind of inertia. It keeps going. You see like I start dragging now and I'm letting go right now, but there is like that kind of inertia. It's kind of cool. It's more realistic, I would say. So you can use that as well to make sure that's happening. Okay, so this is all I had for today. Now this is still not everything. What we have right now, there are some I would say some loose ends that we need to tie up. For example, if I resize my screen, I would like this guy to also be resizing my renderer, my like camera with that, but we haven't done that yet. Also, since we are adding this whole thing in like a website, and we want to make sure, like if I go back to my home page and then decide to, for example, come back again to that page, I want to make sure that I can still see that thing. Right now you don't see that. You only see it if you come through, like your entry point is that Three.JS endpoint. But these are the things that I'm gonna explain more in the next video. We will be like destroying this object, and then like when we are coming back again creating it. So those are the things that really matter for your website performance. All these things that we add here, like this set pixel ratio or like anti-alias, all these things are performance things. You are adding this anti-alias, true, you're fixing something, but it might affect some performances on some machines. So those are like some performance stuff, but also you need to make sure that your user is having a good experience when going from one like page to another page. And most of the videos that I've seen online, they don't like explain these things, and it took me a while to understand and like kind of like figure out how we should like take this into consideration, because like at the end of the day, you're not gonna just have this thing in your website and that's it. You're gonna have multiple pages. You might have Three.js stuff in all pages, some of the pages, or just one page. You don't want to like negatively affect the performance of your website if you only have Three.js in one page. Once you're done with it, you want to destroy it and get rid of it. So we'll talk about all those things in the next upcoming videos. And I think for this video, this is all I wanted to show you. It's just a quick introduction to Three.js and things that we can do. Definitely go check out their documentations and also their showcases. It's just like great inspiration that I've used in my website as well, and the other website that I've created. I will put the final code as of right now Also probably another branch. I'll create another branch here, like part 1 final or something, and you can see that. You can go get it. I'll put a link in the description of this video anyways, so you know exactly where to go. With that, please, if you found this video helpful, make sure to like it, and if you haven't done so already, please go and subscribe to this channel, hit the notification bell on. I'm gonna do a lot more videos on Three.JS, GSAP library, all these cool things, and I want to make sure that you guys are all know when I publish new videos. And of course, if you have any questions or comments, make sure to leave those comments in the comment box below. I'll try to get back to you as soon as possible. Thanks a lot, guys. I'll see you soon.